Hello, and welcome to another IB Math Speedrun me, Vince. So we will be finishing up chapter 3.4 in the speedrun, and we're going to be talking about the sum and product of the roots of a polynomial. So let's jump right in. So, as a direct result of being able to write out the roots as, factors of a polynomial, x minus a, x minus b, x minus c, we can also get their product and their sum by looking at the coefficients of the resulting polynomial. I guess we can try it out here. So if we try to expand this very simple polynomial, we have x cubed, and then this would be minus a plus b plus c x squared. I hope you can see that, because minus a times x minus b times x times x and minus c times x times x. And then we would have plus ab plus ac plus bc x plus abc. So this would be a very, minus abc in this case. So this would be a very simple expansion. But what can we derive from this? Well, because we can see we are sort of binomially expanding this polynomial in a sense. If we're given a polynomial like this, well, we can see the sum of these, what's it called? The sum of the roots will actually be equal to the coefficient of the n minus 1 term. In this case, x is to the x squared term, since the degree of the polynomial is 3. 3 minus 1 is 2. And the negative of that term divided by the first coefficient, because if, say, we put 2x in front of all of these polynomials, and this would be 8x cubed, but this would also be 8x squared, so we would need to remove that. So this is the sum, and for the product, we would look at simply the last term. So it would be negative 1 to the n times a to the n over the first term, or the constant. And that's how we would get the product of all of the roots of a polynomial. Knowing that, we can already jump into some questions. So let's look at some. So I'll be doing the odd ones. So find the sum and product of all the zeros of these polynomials. So the first one, we have x to the 4 minus 3x cubed plus 2x squared minus 5x plus 4. Well, what's the sum of the roots? Well, the sum is equal to negative of the n minus 1 coefficient divided by the nth coefficient. This would be negative 3 over 1, which is equal to 3. So the sum of the roots is 3. What's their product? Well, this would be equal to negative 1 to the n times 4 over 1. The degree of this polynomial is 4, so we have negative 1 to the 4, which is just 1. And then we have times 4 over 1, which is just 4. So this would all be simply equal to 4. So the sum is 3 and the product is 4. Okay, on to the next one. So we need to find the sum and product of 23x to the 17 minus 5 over 11 x to the 9 plus 13 x to the 4 minus pi over 3 x cubed. X minus 46. And this is very complicated, but in reality, we can disregard all of this information here and just focus on this and this. And it is to be noted that this implies that there is some kind of 0x to the 16 being added here. So what's the sum of all of the roots? Well, it would be negative of this term divided by that term. So it would be negative 0 over 23, and in other words, it would be 0. What's the product? Well, it would be negative 1 times n being 17 here, times negative 46 over 23. Negative 1 to the 17 is, well, negative 1. Negative 1 times negative 46 over 23 is 46 over 23, which is just 2. So the product of the roots is 2. Very simple. So on to the next one. We have a cubic equation, 4x cubed minus 2x squared plus x minus 7 is equal to 10 And we need to find the sum of the roots and the sum of 3 over adjacent roots. So say I equals 0 to n minus 1. We need to find the sum of x to the I times x to the I plus 1. So sum is very easy. Negative 2 over 4 is simply 1/2. So the sum of all of the roots will be 1/2. Now, this is a bit trickier, but what we know from this is equal to 3 times the sum of n to the minus 1 of 1 over x to the I times x to the I plus 1. And there is a thing that we can exploit. It's because it's a cubic equation that we only have 3 roots. So it's simply equal to 3 times 1 over x to the 1, x to the 2, plus 1 over x1, x3, plus 1 over x1, 2, x3. And we can exploit this even further, because if we put these all under a common denominator, we get 3 times x1 plus x2 plus x3 over x1, x2, x3. And so as you can see, it's the sum, 3 times the sum over the product. Well, the sum of these numbers we already have, it's 1/2. So we need to find the product of the numbers. And the product, we actually want to move this here over here, so negative 17 is equal to 17 over 4, which is, So we need to have 3 times the sum divided by the product. And so if we cancel this out, this becomes 2. So we have 6 over 17 as the final answer. Yeah, pretty simple. Okay, on to the final question. We have a Quartic equation, 6x to the 4 plus 2x cubed minus 11x squared plus 13x plus minus 3 is equal to 0. And we need to find first the sum, and secondly the sum of I equals 0 to I equals n minus 1 of 6 over n minus 2 actually, 6 over the first root times the second root times the third root. I mean, I times I plus 1 times I plus 2. So the sum is pretty easy again. Negative 2 over 6, negative 1/3 is the sum of your numbers. So the product, or not really the product, as we can see in the last equation, you can rearrange this into 6 over, and then this time it's going to be the sum of the numbers divided by their product, which is equal to 6 over six times negative 1/3 over, and then the product of the numbers is negative 3 divided by 6, which is negative 1/2. So we simply have, finally, I think the answer is simply 4. So that is the final answer. So that was a pretty fast speed run. I hope that you've learned a lot with speedrun about sums and products and other stuff about polynomials, and I hope to see you in the next speedrun. See you then.